Hello and welcome to the next lesson in the quadratics unit. So today we're going to remind you of how we can use factored form to get zeros, and then we're going to go to the next step and use those zeros to get other things that we're familiar with as well. So my idea here is that we'll do a little bit more work with factored form, and then in the next lesson we will go back to the actual factoring process and then do this process with it, right? So we emphasized in the past, we looked at different properties of quadratics and we looked at factoring, right? And then now we're going to use factored form some more, right? So things we can get from factored form, and then we learned about factoring. Now we're going to see some more we can do with the factored form, and then have one more chance at factoring and using it afterwards, all right? So to combine all the skills. So here we go. Things that we've seen recently here from just as an opening question here, right? The review. If we want to determine the x-intercepts, then we would, no, I guess I should rearrange this a little bit, but I'll move this so I can do that here. For this one here, basically you'd say, okay, well, I'll set for the x-intercepts, set I equal to 0. And so we'd have 0 equals x plus 1 times x minus 3. And then we can go through the whole process of saying all this, and you should communicate like this. The whole process would be to show all of the steps as to how it happens. I'll cut to the chase here to show the final result, though, because I want to emphasize the kind of knowledge that you can take advantage of in an easy case like this, right? So we can just jump to that, knowing that it's the opposite signs. If you're doing all the work in either this kind of case or more complicated cases, you would just set the thing equal to 0 in each case, and you would just solve for x. So take away 1, take away 1. In this case, we add 3, right? So we would have, of course, the answer in the end that would give the x is -1 and x is plus 3. Okay. Just a reminder, other ways of saying this, if I had said determine the zeros, literally the exact same thing. If I said determine the solutions or roots, the only difference is this would already be 0. Okay, these definitions and names and so on focus more on the equation. Same as this one, this is more about equations, whereas the x-intercept's more about the graph and those locations. So this is terminology to do with equations themselves. Like I said, where this one is more about graphs and locations. So like x-intercepts on the graph, basically. All right, so it's already just all worked out. I forgot that I had done that, to be honest. So like we did here, I'll just reveal that stuff and show it later. We don't need to do that right now. And these pages are just showing the equation equivalents. So those aren't a big deal. They're just what we've talked about. Maybe I'll reveal it all just right now, just so I can say anything that comes to mind here. But obviously there's the normal stuff, and use the mouse instead here, quicker. Right, so that's what I showed already. And then so you say, therefore, the x-intercepts are that, and you could graph those x-intercepts, of course. If someone was saying, what are the zeros? It's literally the exact same thing, except they just would have said, what are the zeros for this quadratic? And you'd still set y equals to 0, because it would have been y equals. If they wanted to know the solutions of a 0 equals version of this, then, of course, you just solve the same way. Or if they said, what are the roots of this thing? Same stuff. If the equation wasn't equal to 0, we'll see how to do this. Yeah, I guess we could do that now. I'll come back to that as a lesson, but if it's equal to 12, let's say, you'd have to multiply this out and then take away the 12 from both sides to get a 0 version, right? Because obviously this process of saying 0 and 0 wouldn't work. Okay, so we'll be doing that soon. We could do that soon as well. But the one I want to focus, the part I want to focus on today is the axis of symmetry and vertex, getting that from the zeros. So if we have the original equation here, so we have this thing, right? And so if we want to get the axis of symmetry, the idea is we know that equation here actually. Right? We have this, and we already did this in previous work. So in part I, we determined the zeros are -1 and 3. And so in the picture that I graphed too as part of this, I'm just going to grab that rough picture and point out here the idea that, so if you know the zeros are there and there, then you would know it's going to be a quadratic that, is, we can tell actually that it's positive, it opens up, right? So if it opens up, it's going to have to be something like this, right? Which means we know that the axis of symmetry would be somewhere like that. And in fact, most people would say, I just have to get it drawn a little bit better, but it's in the middle, right? So that's known. So this is in the middle, right, of the zeros. Well, we can do that mathematically as well. We know that it's in the middle of the zeros. And so to find the middle of anything, finding the midpoint, you might remember this from grade 9, but if not, it's just sort of logic, right? Where you just add things up and divide by 2. It's the same as what you think of as finding the average. So same as average. Now, if you had one test that was an 80% and one that was a 90%, and they're worth the same, you average them up, you get the middle mark, right, of the 85, 80 plus 90 divided by 2. So you just add them up and divide by 2 to get the middle. And so that would give us 2 divided by 2 in this case would give us a 1, which you can see that's kind of where it was on my graph when I just sketched it based on it being somewhere in the middle, right? So that's your process. You just find the midpoint, and then it's the equation of the axis of symmetry. And of course, it's also the x value of the vertex. So the x of the vertex equals 1, or xv. I might use it as, or show it as. Okay, so we now can figure out the vertex, the x value of the vertex, if we know the zeros, if we started with factor form, something that we can do now. So it's a new process that we have available to us as a tool to use. So then the next step is, if you want to get the actual vertex itself, well, then we know that we have the 1 so far, and then we have the y value that we're wondering about. And so, of course, probably pretty obvious, I'm hoping that, you could just plug the x value in, right? Plug the x value in and just calculate what the y value would be. So that's what it's going to say here. Of course, we know the axis of symmetry is the x value of the vertex. That's important to recognize. So it's in the note officially. And then we just put that value in and calculate, right? So we can put in that 1 in both spots. We end up with a 1 plus a 1 and a 1 minus a 3. Separate those out a little bit for you. Group, ungroup. There we go. So we end up with a 2 times a -2, and so we have a vertex of -4, right? A y value of the vertex of -4, and so then that y value can go in and end up with the actual vertex at 1, -4. Okay. So if we were doing this graph here, we have all this information. We did this in part I, and then later on we did, this maybe, I don't know if it was II, and then whatever it was, letters wise, but we did each part, right? So we have zeros at -1, 3, and we know that the vertex is at 1, -4. At that point, you can sketch that thing, and again, we've sketched this, we've graphed the quadratic with much higher level understanding of things than what we originally started with. Remember, our original skill was y equals whatever number x squared plus number x plus number. We just did a big table of values. It was kind of blind, and we end up with this picture. We really didn't have any clue what it should look like. The only thing we knew was the y-intercept value. Okay. Yeah. So there's a lesson coming up soon that will do this too. But notice that, of course, we could have it all on this page if we wanted. If I had have multiplied this all out, I would have gotten that version. So that would have been x squared, a -3x, and a plus, so a -2x, and a -3. just as a refresher of that. So the -3 value, you see like, oh, look at that. My rough sketch nailed it pretty good, didn't it? But obviously you could make sure if you did a little extra work as well. But the main idea of this lesson was to get the midpoint, get the vertex, and then be able to say, okay, well, I can sketch a pretty good version of this. Okay. So there's just another example for you to try. Press pause, go use it from the lesson file that's posted, whatever. And then there is a solution for this one posted as well for you. Spoiler alert if you want to do it yourself and not see stuff. But yeah, the only difference in this one is you have the full version of the factor, so you have to, it's easier for you to solve nicely for it and so on. All right, so there you go. That's the new work. The practice. These pages down here were just to make it easier for me to print for my in-person class. Up here is the assignment that I want you to use for practice and submit for feedback. All right. Till next.